Oh, hello there, and welcome to our laboratory. I'm Dr. Healy, and I'm Dr. Convertini. And we're here today to disprove Pokemon.
Whoa, slow down. We're just here to talk about what they got wrong about Pokemon.
That most people think they know, but they don't.
So, we're going to talk about the difference between evolution and metamorphosis, genetic variation, and interspecies breeding amongst Pokemon.
And now we're gonna go interview some folks, so follow us. We're gonna go interview some common folk about what they think about Pokemon and whether it's actually evolution.
Excuse me?
Yes, little
Can we
bit.
ask you a question?
Sure.
So, in Pokemon, when a Pikachu turns into a Raichu, what is that called?
Sounds like evolution to me.
Is that correct?
I think so.
Really?
So, our first question is for Ash Ketchum, Pokemon Master himself. How you doing, Ash?
Great, thank you.
Awesome. So, when Pikachu turns into Raichu, what would you call that?
Pikachu evolves into Raichu, so it's known as evolution.
Evolution, and you're positive about that?
100%.
Unfortunately, Ash, I have bad news for you. That is metamorphosis, not evolution.
In the Pokemon world, when a Pikachu turns into a Raichu, it is known as evolution. However, the correct term for this process is metamorphosis. Metamorphosis occurs when an individual changes form or shape suddenly, and the second stage traits are not maintained in the offspring during reproduction. It occurs within an individual and within a generation. Thus, when a Raichu reproduces, the offspring would be a Pikachu, as shown here. In order for Pokemon to have gotten evolution correct, they would have had to change many things. Evolution is known as the change in frequencies of traits in a population from generation to generation, with traits being maintained in the offspring. Thus, it would take an entire population of Pikachu to change from one generation to the next in order to be considered evolution. As shown here, a mutation occurs that changes the ears on the Pikachu from short and yellow to tall and black. This trait is deemed advantageous to the Pikachu's environment, and thus this Pikachu survives and reproduces, passing on the trait to its offspring. Over generations, the frequency of this tall, black-eared trait increases until it is the majority of the population of Pikachu, as it is beneficial to the survival and reproduction of this Pokemon.
Let's go ask someone. Hello, can I
Hi.
ask you a question?
Sure.
Awesome. Do all Pikachus look alike?
Yes.
So, would you say that there's genetic variation between them?
No.
Aha! Another wrong in the Pokemon universe. So for our second question, we're here with Ash yet again. So Ash, would you say that all Pikachu are the same?
They phenotypically look the same, but I tend to think that mine is the best out there.
Interesting. So, would you say that there's genetic variation between them?
Well, from what I just said, I conclude that there is no genetic variation there.
Wrong! In the real world, not Pokemon, you would see genetic variation in a population.
In the Pokemon world, all the individuals in a species phenotypically or physically look the exact same, regardless of their sex, age, and environment. In essence, they are the exact clones of one another, even though they reproduce sexually. This indicates that all Pokemon of the same species have the exact same genes, also known as our hereditary information, and thus have no genetic variation. In normally sexually reproducing lineages, there is both genetic and phenotypic variation within a species. Genetic variation occurs when there are differences in the genetic sequences within the individuals of a population, occurring through crossing over during meiosis and random mutations. Thus, since Pokemon reproduce sexually, their gametes should cross over and recombine to new sequences during reproduction, creating a variety of genetic variation among individuals. Now, genes are partly in control of the creation of the individual's phenotype, or how they look. Since there should be a variety of gene sequences, there should be a variety of phenotypes in a population, because different genes create different traits. As shown here, there are a variety of ears, tails, and body images within this population of Pokemon. Also, there is no phenotypic plasticity among Pokemon species in the Pokemon world. Phenotypic plasticity occurs when an individual with the same genes have different phenotypes depending on their environmental factors. all Pokemon in a particular species are phenotypically the same, regardless of their environment. Environment has a huge impact on both the phenotypes and genotypes of an individual, but the Pokemon world acts as if there is no effect.
And now we're going to talk about interspecies breeding. Follow me. Hello.
Hi.
Okay, so if a girl Squirtle and a boy Pikachu were to have a baby, what would it look like?
The baby would look like a combination of the two.
Well, actually, in the Pokemon universe, it would just look like the Squirtle because the Squirtle is the mom and they all look like the mom. We'll be asking Misty. So, my question for you is, if you had a boy Pikachu and a girl Squirtle and they had a child, what do you think it would look like?
Well, it would clearly look like a Squirtle because only the mother's traits are passed down.
Well, in real sexual reproducing lineages, it would actually look like a combination of the Squirtle and the Pikachu.
Lastly, the Pokemon world got breeding and reproducing wrong among Pokemon. According to the biological species concept, a species is a group of individuals who can only reproduce viable offspring with one another. In Pokemon, any individual can reproduce with any other individual, regardless of their species identity. Thus, according to the biological species concept, all Pokemon are considered one species that can interbreed among one another. In the Pokemon world, when two individuals mate sexually, the offspring become exact clones of the mother. Thus, only the mother's traits are passed down to the offspring, even though the mother engaged in sexual reproduction with the father. The offspring look as though the mother underwent asexual reproduction, with no father involved, and merely budded this new individual that is identical to the mother. As shown here, when a seal and Squirtle reproduce, another seal is created, as the seal was the mother. In normally sexually reproducing lineages, offspring are a combination of the mother and father's genes, and thus have phenotypic traits referring to both the mother and the father. As shown here, when a seal and Squirtle sexually reproduce, they create an individual that is genetically and phenotypically a combination of the mother and the father, as their gametes are randomly passed on to the offspring.
Why are you trying to tell me about Pokemon, honey? I've been watching Pokemon before you were even born. Trying to tell me how Pokemon evolved.
So for our third question, we're gonna ask you
Nope, it's our second. Nope.
It's our second question.
Hi! And now we're here with two master Pokemon players. Do you have anything to say?
Oh,
Pokeball, go!